All right, this is Cashford. My name is Mr. Hussein. In today's video, we're going to be looking at simple machines in physics. So I really want us to summarize this topic so we can easily understand how they would phrase exam-based questions. Under the Zambian syllabus, things are quite simple. So I'll try by all means necessary to simplify this for everybody to understand. All right. Let's begin by defining what a simple machine is. So a simple machine is simply any device that makes work easy. So any device that will make work easy is regarded to be a simple machine. So we have so many devices that make work easy, but my main focus is not to look at such devices, but for us to understand what we're trying to talk about. So the main goal under this topic is to actually understand that we have particular devices that make work done easy. Now, work done is easy to understand because it's just a product of a particular force by its displacement. With what has been said, we can clearly understand that simple machines are just devices making work done easy for us. So now on this topic, the particular terminologies you have to know. So let's look at the terms used. The first term is effort. So what is effort? Effort is simply the force applied to a machine in order for work to be done. So this is the box on a leveled ground. This box is regarded to be a system, in other words. So when a particular force is applied to the box, that force is regarded to be the effort force. So remember that effort is just simply the force applied to a machine, box, or system in order for work to be done. Remember, effort is a force, so its units of measure are newtons. Say, if your answer is 4, you say 4 newtons, and this is your effort force. Moving away from effort, we have the next term, which is known as the load. So now, we can clearly understand the load in a simpler manner. So this is a box on a leveled ground. Load, in simple terms, we could actually say it is the weight of an object. So we can clearly understand that the load is just the overcome force, because once we apply an effort to this machine or box, you will realize that it will be overcoming another force that is exerted on this box. So when the force being exerted on the box is overcome by the effort, then that force that has been overcome is regarded to be the load. We can as well say that the load is simply the force that is produced on the other end. So when an effort is applied to the box, which is a machine, it will produce a displacement that will be in a particular direction of the effort, and that force produced on the other end is also regarded to be the load. But be mindful that the weight of an object is the load. Under certain Zambian past papers, you realize that most questions will involve you being given the weight of an object and you'll be asked to calculate other things that will involve the load. So be mindful that weight is just a load of a system. Load is also force, so its units of measure are also newtons. Say, if your answer is 10, we'll say 10 newtons. Okay, let's continue. The third terminology is mechanical advantage, which is just symbolized as MA. So now mechanical advantage is the ratio of load to effort. So we can just deduce by saying mechanical advantage is equivalent to load over effort. Now, since mechanical advantage is a ratio, it has no units. But the definition of mechanical advantage is simply the ratio of the load to effort, as we have denoted it by this formula. The next term is simply velocity ratio. Velocity ratio is the ratio of the distance moved by the effort to the distance moved by the load. So we say velocity ratio is equal to effort distance divided by load distance. In a similar manner as mechanical advantage, velocity ratio has no units. So if your answer, say, is 5, you just say 5. Because velocity ratio is simply a ratio, and ratios have no units. The last terminology I want us to discuss is efficiency. Alright, so efficiency talks about how efficient a machine really is. But efficiency is well defined in accordance with its formula. We say efficiency is equivalent to the mechanical advantage per velocity ratio expressed as a percentage. So efficiency is mechanical advantage over velocity ratio times 100%. So your answer, say, $20, you will say 20%. Now, efficiency in real life is never equivalent to 100%. Now, the reason why efficiency in real life will never be equal to 100% is because some of the heat energy is lost due to friction. Now, friction is a type of force that is experienced between two surfaces that are constantly rubbing each other. So be mindful of this point that I've just said. In real life, the efficiency can never really be equal to 100% because some of the heat energy is lost due to friction. But I'll explain more on efficiency as we look at some of the types of simple machines.